Hello students, welcome to Aditya Academy. I am Dr. Ragini Arora and today we are going to start 10th chapter from NCERT, which is circles. I hope you must have watched the introductory video of this chapter. So we are going to start questions in this video. The first question says, how many tangents can a circle have? Right. So we have learned that a tangent is a line segment which touches a circle at a particular point, and this point is called point of contact. Point of contact. So now we know that tangent is a line which touches the circle at a point, at a particular point. Let this point be P. Now he is asking us how many tangents a circle can have. So you can see that a circle has infinite points. A circle has infinite points, and there is no restriction that we cannot have tangent on every point. Like a circle has infinite points, so a circle can have infinite tangents, right? That means we can draw tangent at every point, though it is not practically possible to draw it here and show it to you, but still you can see that you can, if it is possible, you can draw tangents at any point, irrespective of how many tangents you can draw right now in this picture. So it can have infinite tangents practically, right? The next question is, we have to fill in the blanks here. A tangent to a circle intersects it in dash points, point or points. So now we have just learned that a tangent is a line which touches the circle at a point. That means a particular point. It can only be one point, not more than that, right? Then we have a line intersecting a circle in 2 points is called, we had learned in the introductory video that a line which cuts a circle at 2 distinct points is called a secant. A secant, right? It cuts, like this be AB. AB is a secant. A secant cuts a circle at 2 distinct points. You can call this an extended chord which goes outside the circle, right? Next is, a circle can have dash parallel tangents at the most. Now we had learned in the introductory video that if we have a circle and if we have drawn one tangent here at a point A, then parallel to this tangent we can have only one tangent. This is also similar to the concept that you have learned. If we have a line through a particular point, we can draw a line parallel to the given line, not more than one. Only one line can be drawn parallel to one line through a point which is not on that line. Similarly, this parallel line is already existing. Let's say this A is already existing. Now we have a point here and we can have only one parallel line which can be parallel to this tangent, and it can only be one line which can be drawn parallel to it. So a circle can have 2 parallel tangents. That means 2 parallel tangents at a time, right? The common point of a tangent to a circle and the circle. See, this is the point which is common to tangent as well as circle. This point is called point of contact, right? Point of contact. This point is common to both the tangent as well as the circle. So the next question is, the tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center at a point Q. See, this is, now see, a tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O. Center is O. A line is being drawn from this center O. Radius is 5. And he says now the tangent PQ. This is like this. P, this line meets through the center O at a point Q. Now PQ is a tangent, right? And this tangent meets this line which is coming from the center at point Q such that OQ is 12. This whole length OQ is 12 centimeter. And he says the radius of this circle is 5 centimeter. Just read the question again. The tangent PQ at a point P. P is a point of contact of this tangent and the extended part is PQ. Now the point P of a circle of radius 5 centimeter, radius of this circle is 5, meets a line through the center O at a point Q such that OQ is 12. So this is the figure that we have drawn by reading this question. Now this he is asking now, find the length PQ. This we have to find. Now what we had learned in the introductory video and the theorem is that the radius at the point of contact is perpendicular to the tangent. See, OP is the radius at the point of contact P. PQ is the tangent and P is the point of contact, and if we draw the radius at point P, this is perpendicular to the tangent PQ. So we can write here OP is perpendicular to PQ, right? Radius at the point of contact is perpendicular to the tangent. So here point of contact is P, OP is the radius and PQ is the tangent. So angle between OP and PQ becomes 90 degree. That is angle OPQ becomes 90 degree. Right? Now in this right triangle, if this is 90 degree, the side opposite to 90 degree is hypotenuse. So in the right triangle OPQ, we can apply Pythagoras theorem here. Side opposite to 90 degree or right angle is OQ. So square of hypotenuse is equal to the sum of squares of other two sides by Pythagoras theorem. So now we have PQ, we have to find PQ square. We can write OP is 5 and this is 12 square. So here we have 144 is equal to 25 plus PQ square. So we can solve it here. PQ square is equal to 144 minus 25. That means PQ square is 14 minus 5 is 9. 3 minus 2 is 1. PQ square is 119. So this gives us that PQ is square root of 119 centimeters. So this is the correct option. So we can say answer is option D, which is square root of 119 centimeter. Right? Next question is, draw a circle and two lines parallel to a given line such that one is a tangent and the other is a secant to a circle. So here, this is a very basic question, like a circle is this. Given is a circle and a line. What we have to do, we have to draw two lines parallel to a given line. This is your given line. And this is the circle the question is talking about. Now he says we have to draw two lines parallel to a given line such that one is a tangent and the other is a secant. Now what is a tangent? Tangent is a line which touches a circle at a single point. So here I am drawing a tangent. This line is parallel to this line. I am drawing it with the right rough hand, but you have to use a scale to draw this line parallel, right? And this is the tangent. Here P is the point of contact. So this given line, we have drawn one tangent parallel to the given line. And next we have to draw a secant which is parallel to the given line. So we can draw it anywhere inside this except particularly the center. So secant is a line which cuts a circle at two distinct points. Let AB be the secant and PQ be the tangent. So this was the given line. We have drawn one tangent parallel to the given line and one secant parallel to the given line, right? So this was all about exercise 10.1 from NCERT. I hope these were the basic questions. So you liked watching this video. Please do not forget to like, subscribe and share it with your friends. Thank you.